Good morning and welcome to this Chemistry World webinar. I'm Ben Valsler, Chemistry World's digital editor, and welcome to GoToWebinar, which is the platform we're using for today's topic. The key thing about webinars is, of course, interaction. So we really want you to ask your questions. GoToWebinar makes that quite easy for you. You may be joining in a browser or a standalone product, but you will find a questions or chat box somewhere on screen. It may in fact be the box in which I'm saying hello in right now. So any questions you have at any point throughout the presentation, please do get them in there. We have about 10 minutes or so for Q&A after the presentation, and we'd love to make sure that we get through your questions. So that's the most important thing about today's presentation, and that's what you want to know. So that's the platform out of the way. Let's talk about today's topic. Now, today we're learning how to speed up process development by making more from your offline and online data. We're going to hear how the biotechnology R&D team at Clariant uses statistical modeling techniques to speed up their process development of their bio-ethanol product. And now that's developed by Clariant, something called Sunliquid, is an innovative and sustainable technology used to produce bioethanol. So over the course of the next hour, Clariant group leader Benjamin Fürst will explain the process and explain how he and his team used modeling techniques to optimize fermentation processes. Ben's joining us now. So in this session, you'll see how to maximize insights and understanding of the process by modeling data from all of your different data sources in the context of the Functional Data Explorer platform in JUMP. Now, that's my first mention of JUMP, but JUMP are our partners for this and for many other webinars that we do. They develop software platforms that help scientists to design the right experiments, to develop better processes, to save time, money, to be more efficient, and to use their data better. So they're a regular partner with Chemistry World. They do make things better for scientists, for chemists, for researchers, and in industry. And we are delighted that they continue to sponsor a series of webinars with us. So thank you, JUMP. And thank you as well for finding Ben Fürst, today's guest. Now, over the course of the next hour, you should see how you can use JUMP, and in particular the Functional Data Explorer platform in JUMP. You'll see a practical demonstration of the software. It'll highlight the advantages of using JUMP's graph builder as well to help to lead teams and subject matter experts and to communicate your results better. So you should gain a practical understanding of the scope offered by that. You'll be able to leverage data analytics within your team and understand how data viz can help you to know your data better, which will enable you and your team and others in your business to collaborate and make better decisions. Now, Ben Fürst, who you just saw on screen, has pre-recorded the presentation for us, but is with us live to take your Q&A. Now, he is a group leader in bioprocess design at Clariant. He has worked for Clariant since 2014, leading the bioprocess design group, which is in the Department of Biomanufacturing and Group Biotechnology. He's got a Master of Engineering in Biomedical Engineering from TU Dortmund University in Germany. We're delighted he's been able to join us today. Now, also, and probably mostly behind the scenes, we do have a JUMP expert, Manuel Romeo, who is a senior systems engineer for JUMP. He will be able to answer any questions that you have about JUMP specifically, what it can do, how best to get started, how to achieve certain things with it. So any questions you have about JUMP, Manuel will be able to answer as well. He may also, if needs be, pop up in the Q&A session at the end, but he's more than happy to be answering your questions throughout in text. So any questions you have about Clariant, about Sunliquid products, about JUMP, about process design, we're really keen to hear from you. Now, the first step of hearing from you is finding out a bit more about you and your data sources and how you work. So we're going to run a quick poll that will help us to get to know you a bit better. Here we go. Do you gather offline and online data to optimize your processes? And the questions here are, or the answers are yes, I have been for some time, no, but I'd like to, or not sure. Now, of course, you may be collecting all sorts of different data types and not exactly certain whether they're defined as online or offline. So it's in that case, you would definitely tick, I'm not sure. We'll give you just a few seconds to get your answers in. And in the meantime, a little reminder, those of you who join us live, we will be sending a certificate and also a link to the recorded version of this webinar. So if there's anything that you miss, or if you have to leave early, or if you just want to watch it again, you'll get a link to that in your inbox in the next few days. Those of you who aren't joining us live are now currently watching the video, thank you for watching the video. Please try and join us live next time. It really does make all the difference with that engagement, being able to ask questions. But either way, we'll send a link to the recording. Some people ask if we share our slides, and we prefer not to share slides for our presentations because we think what's important is the context of what's being said along with the slides, and also you're going to see some live jump demonstrations that are embedded into the recording that would of course be impossible to share with slides as well. So you get a link to the full recording, the full context, all bells and whistles instead of just a flat slide deck. So once again, thank you very much for joining us. Thank you for voting in the poll. I think that's probably quite enough in the poll now. So we will just use those results to help us pick the right sorts of questions, but I can see that about half of you are currently using this, and only a relatively small percent, about 17% of you, not sure, and the remains no, but you'd like to. So you're clearly in the right place to find out the sorts of benefits you can get from gathering different sources of data. Now that's enough for me. Keep your questions coming in as we go throughout the webinar. I can see Susan has already used the platform to be able to warn us that she wasn't able to do the survey. Sometimes, depending on how it's set up, the survey won't work for you. It might be that it's full screen or that your browser won't let you and so on. Don't worry about that. You can do what Susan's done and just send your answer in as if it were a question. So thank you, Susan. Thank you for joining us. I know you're a regular webinar attendee. That is more than enough from me. I'm going to hand you over to the other Ben now, Ben Fürst. As I said, pre-recorded presentation, after which he'll be here in the flesh to answer all of your questions. So take it away, enjoy the video.
How to make more from your online and offline fermentation data, and how to speed up your bioprocess development with statistical modeling. I'm Benjamin Fürst from Clariant, and today I will show you how to do this in JUMP. I will lead you through a hands-on presentation how to combine different modeling techniques so that in the end you have a combined profiler where you can look at all the responses online, offline at one time and see what impact your process parameters have. I am a biochemical engineer by training. I work for Clariant at the group Biotechnology, and I'm group leader of bioprocess design. The agenda for today will be introduction for Clariant and into the process technology Sunliquid, and then I will dive into the topic of my talk and go into the statistical analysis of fermentation data. For the modeling of offline responses, I call it standard statistical modeling. I will use the FitModel platform and will especially focus here on the extrapolation control, which came in with JUMP Pro 16. Next level analysis will be modeling the online data, and I will use the same data set. And for this, I will use the functional data platform, also a JUMP Pro feature. Let me share some key figures about Clariant. Clariant is a global leader in specialty chemicals. To the right, you can see the Clariant business numbers. We have a 3.9 billion Swiss franc sales in 2020. We have a 15% EBITDA margin and over 13,000 employees worldwide at 85 production sites. Clariant consists of 3 business units: Care Chemicals, Catalysis, and Natural Resources. Care Chemicals, they produce, for example, ingredients for shower gels and shampoos, which you use in daily life. Natural Resources, they produce, for instance, bentonites. 40% of all vegetable oils are clarified with bentonites from Clariant. Catalysis, of course, they sell all kinds of catalysts. And they also contain the business line biofuels and derivatives. This business line sells Sunliquid. What is Sunliquid? Sunliquid is a technology which came from the group Bio R&D Center where I work. Basically, it's a biotechnological process for producing bioethanol from non-edible biomass. How does it work? So we use, just to stress this again, that's the second generation bioethanol production. So we use non-edible biomass feedstock, so basically agricultural residues. This can be wheat straw, bagasse, corn stover, municipal waste, or forestry residues. We put that into the Sunliquid process, and we at first turn them into cellulosic sugars, and then to cellulosic ethanol. The nice thing about this process is that it can be used as a platform process for not only bioethanol, but for other sustainable fuels or even bio-based chemicals. And the development of this process started in the group biotechnology, where I work. You can see, if I'm not in home office due to Corona, I'm working here in that corner of the R&D center in Planegg. That's located just a few kilometers outside of Munich in Bavaria, in Germany. The center was inaugurated in 2006, and we have over 100 scientists and technicians working there. The competence fields of Group Bio are biofuels and derivatives, Sunliquid, industrial enzymes, and bio-based chemicals. Within the Biotech R&D Center, we have all the expertise to develop new products and technologies under one roof, starting from small, tiner, micro-titer plates over a shake flask to up to 100-liter bioreactors. Here in the picture, you have a small peek at our technical center fermentation. To the right here, you can see the Sunliquid pre-commercial plant in Straubing, which is just 1.5 hours from here. It was built 2012 and can produce about 1,000 tons of ethanol per year. And we're able to test a wide range of different biomass feedstocks there. Maybe some of you are aware that Clariant is commissioning a commercial-size bioethanol plant in Podari, Romania at this time. To say, as a biochemical engineer, seeing this plant, that is a really, truly impressive thing. The size of the buildings and the equipment there are in biotechnological means really tremendous. And I see this as a real flagship for biomass conversion here in Europe. And to my opinion, that is one of the major biotechnology projects we have in Europe at this time. And really makes me proud to see that we are turning our Sunliquid technology from bench scale to production scale. The plant transforms 250,000 tons of wheat straw into 50,000 tons of bioethanol per year. And to give you maybe a more handleable number, that means one huge bale of straw, about 500 kilos, goes into that plant per minute. The Sunliquid technology enables you to produce the bioethanol in a very integrated way. Side products like lignin are reused in a CHP plant for energy supply, so generating steam and power, which goes back to the plant, of course. If you're curious to learn more about that technology, please look at the links or feel free to contact me or reach out in the contacts which are given on the homepage. Now, why I'm showing you all of this, what do all the stages have to do with each other? At all stages of the development of a biotech process, you have data about the process. And it doesn't matter if it's a micro-titer plate, a 1-liter bioreactor, or a multi-cube production scale fermenter. You always have offline data, like titers you measure, and you have online data coming from your sensors, pressure, temperatures. And you always want to know, how can you achieve the most efficient process? What can you achieve? How can you achieve the high yields? What are process influencing process parameters? And what sensors do you have to pay attention to get the most of your process? All these points can be addressed with statistical modeling of your process. And JUMP really gives you the opportunity to make more from your online and offline fermentation data and speed up your biotech process. Let's go. Since my talk is going to evolve about data coming from a fermentation process, I want to put everybody on the same page concerning how does a fermentation process look like. This is a basic overview over a fermentation process with a DSP. I will focus on the main points here. So you come in with a test tube that's a few milliliters, you propagate your organisms in a so-called seed fermenter. And then you do, in the next scale, the fermentation in the main fermenter, where the product is going to be produced. And then you go into a downstream. The setup here really depends on what the specs of your product are. All along the process, you have different steps, and you have factors which are set for this step. On the top here, I showed just some examples. So seed inoculum amounts, how much biomass you put in here, pH, temperature setting of the fermenter, or even other unit operations, and the raw materials you put into the process, which type, at what concentration. And all of them here are constant. They have a fixed number. So I depicted them here with dots. And of course, you have responses. The responses are the outputs of your process. This can be a harvest yield, so how much product you're going to get in your fermenter, or how good does your DSP perform in terms of some specific response you want to look at. Those are constant, again, because you just have a single point. And you have online sensor data. For fermentation, you usually look at something like a dissolved oxygen called PO2, temperature, pressures. And the important point about that sensor data, it is functional. So you have your sensor data over duration. You have a curve of data. And I can really tell you, you're normally interested in knowing how is everything connected there? How can I make the best of all of the data you have? And normally starts if you want to know from your fermentation parameters, what is your response you're going to have, your often response, something like a yield product titer. And maybe you want to know from your fermentation parameter, how does a typical sensor curve look like, so that you know how to go with your process in a good way. And last but not least, wouldn't it be great here for the last point, knowing at one time point, online sensor has a critical impact on your harvest yield. So using standard software, you will really not get far. You're probably going to lose your focus looking at all the points. And JUMP can really help you in getting those things done. In the following, I want to show you with a live demonstration then how you can do all those things in JUMP. There are several videos in the community really how to use the model platform or the FDE platform, but I like to combine these platforms to put all the results together. So Excel statistical modeling with a fit model platform and with a focus on the extrapolation control. I want to use the fermentation parameters and model the harvest yield. That is where we're going to go for the first point. Normally, the goal of doing this is you want to know what process parameter give a high harvest yield. You want to find an optimum in the design space. Is that optimum stable? And what parameters have interactions? And what parameters are sensitive? And the way you do this, as I already told you, you're going to use the fit model platform. One important point here, I called it here detailed evaluation by and with subject matter experts. I believe that the real speed for process development comes from a mutual understanding among the experts you have. It doesn't matter if it's a fermentation engineer, data analyst, or a manager. Every expert must understand a little bit of the language of the other expert. So it's really crucial that the subject matters share a common language. And I believe using JUMP enables you to speak that common language using the profiles JUMP provides and the reports JUMP has. Let's get back to the topic. This was it's called a real life experiment, and the data was coming from it's a planned experiment, and it was not intended for the usage of statistical modeling. That means the design space was not optimal. I put a plot of 3 parameters here. As you can see, of course, there was some kind of structured approach, but not in all dimensions, not in all parameters. You can see on this axis, we don't have so many points. So one of the challenges here was the limited design space. And here, especially the extrapolation control in Jump Pro comes in very, very handy. Yeah, let's get into Jump. I'm gonna load up Jump now. So you have that is my data table, and of course already scripted the report. This is the profiler for that model I chose. At this point, I will not go into the details of the modeling. I assume you already looked at your plots. You've chosen your models, the parameters for your model correctly. So how can you use this for your development? I think that's pretty obvious. You have the harvest yield, which you're interested for your fermenter, in dependency of all of the parameters which I found significant for this model. And one way you can use this, I want to show you a very nice thing you can see with this model. If you look at the seed in the column, that is basically the amount of biomass you put in the process. If you have a low biomass you put in the seed, it means you're not going to have so much biomass during the whole process. And you will see that this parameter alone doesn't have a huge impact on the harvest yield. But now, if you see that moving, if you move that around, there is a strong interaction with component A in the main fermenter. So with less biomass in here, you have the more component A in the main fermenter you give in, the more product you will generate. That is, you can basically say that's a limitation on component A. That makes totally sense. Now, the interesting thing is the interaction. If you gonna put more biomass into the process, that turns around. So what happens here? I have to say, you cannot see that here, what happens there, because you have a different limit. Now it gets to the point where it's interesting. You have to put more data into your model. For instance, online data. You're going to see that in a different sensor. That is something I will show you then if we go into the online data analysis. You can exactly see this behavior there. And seeing this was quite obvious for me. An explanation of that was clear. But just the other day, I showed that model to another fermentation engineer, and he just said, "Hey, having that behavior for that other parameter and temperature, that's totally clear, and we have to look at that." There's something when I talked about that common language that I will be able as a data analyst to understand some things, but not to the same extent as the fermentation engineer does. So it's very crucial that everybody has access to this kind of looking at that. Okay, I wanted to talk about extrapolation control. Extrapolation control comes with Jump Pro 16, and it can be found here. And there are different criterions you can set. I set it here to the first one that basically is Jump to stay within the convex hull of the data you have. If you want to learn more about that, there's talk about controlling extrapolation by Laura Lancaster and Jeremy Ash. The video is in the community. They talk a lot about how you can use that and how are the statistical details behind that. As you already probably noticed, moving around the parameters, those traces here move. That wasn't there before. And that really gives you an advantage in using the model, because you will not go outside the model, outside of your design space. You're not going to make a wrong conclusion from your data. And you can see even Jump splits the data here if it thinks that it's not sufficient data there to do some extra extracting data from that. So for limited design space, extrapolation control is very neat way to go. We're going to use that later. So we're going to need to save our prediction formula. I'm going to save that here, save columns, hit save prediction formula, click, and then it's going to turn up in your data table down here because we're going to need that. Okay, going to get back to my presentation. So just to make a short summary, yeah, the models shown are, we could show expected behavior and most important, unexpected behavior, and use that for next runs. The extrapolation control, especially on limited design space, comes in very, very handy. And we were able to find optimized parameters of the model in the design space. So we identified potential parameters for a higher yield for the next runs. Just a nice side fact, how to interpret stability. I normally prefer to use the simulator here. You can just add that to the profiler. And also I like to use the contour plot, especially when you have multiple responses. So not only the titer, but imagine you have some DSP performance you want to put into your model as well. And then you put them all in a contour plot and limit the areas where you want to have the process, and then you have the target area where you need to run your process to be within all the specs. Okay, especially here, because of this limited design space, you have to emphasize, you have to verify the results with an additional experimental runs, because you were on the limit, the optima we chose for the profiler are on the limit of the model. So you have to be sure that those are correct. But here in this case, we just use them to guide us in the correct directions for parameter setting. Okay, at this point, we have the profiler with the response of the harvest yield over the fermentation parameters. Now, I already hinted it. Wouldn't it be great to have now all your online sensors on there too, so you can see other effects as well? Let's go there. So the next step is online data analysis with a functional data platform. And there you're able to use the same set of fermentation parameters and model the functional data, the online response data, and combine them with your model we just designed. To put that a little bit in graphics, we want to go from, we have the fermentation parameters, we have a whole bunch of sensor data. I depicted all the batches here. And from that data, we want to go to a profiler where we have the lower line is the model I just showed you. And we also have other responses there. There you can see what is a typical response of that set of parameters you've chosen. I drafted a short workflow here, what we're going to do. I'm going to show you that in Jump, of course. And we're basically going to use that we did already, the fit model platform, save the prediction formula. And now we're going to use the FDE platform, fit splines, do the functional DOE, and save that again, and then put everything together in one place. Let's get back to Jump. Here's a set of data. I normalized all the data from 0 to 1. And I'm just going to show you what we want. I will want to show you that on an example of the PO2, that is the dissolved oxygen. That's an important parameter in fermentation because a microorganism, in this case, needs oxygen. And so having sufficient oxygen over the time is important. And the graph builder, essentially, if you want to get people to use Jump, I always would like to stress out using the graph builder, because that's just the easiest way to put data together and make nice graphs. So using other software probably would have taken me to do this, but not 30 seconds. And this is a very nice way to have all the overviews. And where do you want to go? We want to have another parameter here, the PO2. Also, all the information we have in all those batches, want to have collect them here and see what is the typical curve for this set of fermentation parameter we chose. Okay, the functional data platform is here under specialized modeling, functional data explorer. You need your outputs, which are functional. I'm just going to take two here, PO2 and CO2. On the X, you're going to put the duration, and you have to tell Jump how to discriminate between the batches. So you're going to put your batch ID here. Now it's really important to supplement everything you want to need about. So the fermentation parameters, or even other things like the harvest yield, you want to know, you want to do analysis on, you have to supplement it here at this point. If you forget something here, you have to redo a lot of stuff again. Okay, and then you have the first report on the functional data explorer. Jump gives you here that's everything together in one graph. That's not so nice, but here you can see all the data by batch ID. Just want to point out there are nice cleanup tools here. Have a look at them, use them. You don't have to clean up your data before. Even you can thin your data here very easily. Now we have the data here, and now we have to build a functional model of the data. And Jump does that with doing splines. There are different kind of splines you can use. I'm first going to go into the easiest one, B-spline, that is pretty fast, and you can see what it does there. First, you're going to see here in red the splines which were done over your data. And the second, it does a functional PCA down here. So PCA basically is about reducing the dimensionality, and Jump produces a set of eigenfunctions and a set of FPCs, functional principal components. And if you multiply each corresponding FPC with the eigenfunction, you will end up with a functional model. So you can use that to individually model each batch of fermenter you have. So the FPCs are the individual characteristica of a batch, and the eigenfunctions are valid for all of them. And multiplying them, you get each individual curve. That's important to understand, that those FPCs are the characteristicum for the functional data you have. Then you have to decide now, okay, now looking into this, basically you see that spline doesn't get the data very well. I know that up and downs here, those are important, and that doesn't suit me very, very well. So I'm going to remove this fit, and I will do, there are other models. A B-spline basically is a penalized, a P-spline is a penalized B-spline model, and that will do the thing here. Just want to point out there are other ways as well. The direct functional PCA does it without fitting a basis function. If you have a huge data set, that works far faster. For me, I already know from my data set that the P-spline is that what I'm going to need. And you can already see here, this takes some time. So think about your maybe some data reduction that you can get faster through that process if it's important. But be aware that if you reduce your data, you will be losing information about your process. And maybe those will be the important ones. So maybe just take your time in that and just wait for some minutes, grab a coffee. So you can see here already that those splines do fit very good. So this is something I was content with to use. Of course, you can look at the diagnostic plots and see if that's everything suits you. Well, I'm not going to go to. I will focus on that where I wanted to go originally. So keep in mind, where did we want to go? Wanted to add a PO2 curve here, depending on the fermentation parameters. Jump is going to give the option to do a functional DOE analysis. That is exactly where we want to go. Basically, it does, in the background, it does a generalized regression with a 2-degree factorial model. And the estimation method it uses depends on the amount of parameters you have in it. It's either best subset or I think it's a prune forward selection. Okay. Let me make that smaller. Don't need this. But we do need this. That's where we wanted to go. So exactly what we need. We have the PO2, the online response, dependency of our parameters. Just as a side point, if you don't see this modelization fitting, you have to do that maybe more by foot using the fit model platform. But if it's fine for you, you can go with that. Again, you have to save your prediction formula as you want to put that together. Be aware that I'm now in a different data table than I used before. So you're going to hit save prediction formula, click, and then you're going to end up with your, oh, that's still there, with your prediction formula here in that table. And my original model was in another data table. So you have to just combine them in what table, whatever you like, however you like. I just basically copied the formula, and that was it. Okay, then let me show you if you want to put them together. So I put them together in my original table. I have them both here now, the prediction formula of the harvest yield and the PO2 of the POT prediction formula. And how to put that together, pretty easy. You use the profiler, put those functions in. Very important, tick the expand intermediate formulas because you have that eigenfunction there, so you need to expand the immediate formulas. Click OK. I again prepared a script because the original evaluation, that's kind of not so colorful, so I prefer coloring at some point. So I just put those two in here. So that is where we wanted to go. We have our harvest yield, and we have our PO2, and we have all our parameters in here with the dependencies. Now, I promised you that we're going to see more. I'm just going to see, that is the seed inoculum in the component A we looked before, if you remember, and we saw that for low biomass, we have a positive impact of component A in the main fermenter, and having more biomass, that behavior turns. And now we're able to see what's happening. You see here, that is the typical PO2 response to that set of parameters. And already going down here, you can see what happens. I'm going to go here a little bit more down. The PO2 goes down. So in the fermenter, we don't have a limit now of component A, we have a limit of oxygen. That is just the reason why that is not good for the process. And now with modeling your online data and your offline data, you can go one step deeper to understand what exactly causes all your behavior. That's a really great example how you can approach the understanding, especially the speed up of your process development. Okay, gonna go back to my presentation. Yep, basically that is just what I showed you, just with more parameters. It can be, or I added more online responses, and I have also some DSP responses in here. You can put it at whatever extent you like. But be aware, here is no extrapolation control. different models behind each response. So JUMP is cannot put that together into an extrapolation control. So here you might limit your factors over the factor settings of the profiler that you stay within your design space. And you can use JUMP standard to look at the profiles. You just have to do the analysis with JUMP Pro, the FDE analysis. Okay, one more thing. Wouldn't it be great now to know at which time points an online sensor has a critical influence on your yield? So that you basically have the sensor as an input parameter and your yield on this side. So you can exactly say, okay, at this point it's very critical to have my PO2 up or down to have a good harvest yield. Let's go next level. Now I want to use the online data to model the harvest yield. I wanted to, before we start, put that graphically again. And we have, on this side, we have all the PO2, the graph I already showed you before. That's the PO2 over all the batches. And you can see that in the end here, we have, this one's going up, the PO2 sensor. Here, the PO2 is very low. And here it's somewhere in the upper, lower region of the sensor. And in each of these cases, the harvest yield has different behavior. So somehow the individual curves at this time point have influence on the harvest yield. And that is exactly what I want to model. So you can say which sensor yield, profile really leads to a good yield. This is where I want to go. So I'm going to have all the responses here and my harvest yield, of course, depicted and modelized over this case, the FPCs. Remember that I told that the FPCs are the individual characteristic of the response. That is exactly what you do. So I'm going to show that you JUMP as well. We going to start working through that workflow, and basically it's kind of the same, but you just use the data in a different way. You use your online data, the summaries of the FPCs, to model the generalized regression. And then you put everything again together, save the prediction formulas in one data table, and there you go. Okay. I prepared the. Okay, where did we leave? So that is where we stopped the last time. We had our PO2 over the fermentation parameters. Okay, done. We already have the model of PO2 over the FPCs. Now what we need is the individual function summaries. So we need to modelize the FPCs we have for that response with the harvest yield, because that is what we want to know. How do the FPCs contribute to the harvest yield? And now you can set here what you want to export. Basically take all of this. You need, say, formulas, because you want to have the formula of the PO2 dependent of the FPC, and you want to have all the FPCs. You can either, now you have to extract that data because you want to modelize that. You can either do it, save data here, or if you have modelized more than one response, you can do that up here and save data or save the summaries. Then you get everything neatly arranged in one data table. Click that, and then you will end up with a table like this. So you have all your FPCs in here, and the formulas you will need here are there. And now we have to model the FPCs to get the dependency to the harvest yield. You just go to the fit model platform, then you will choose what do you want to model, and that is your it's supplemented. That is why I hinted that you really have to be aware of what you supplement in the very, very first step of the FTE. Now we're going to need the harvest yield here. It has to be supplemented. And then you will, depending on what you want to, how you want to approach it, I normally take the FPCs. And this time I use the response surface model. That might be sufficient for you. If you think you need another model, you're free to use whatever modelization you seem necessary to. And in this case, I put them in individually. Sometimes even maybe just modeling the mean would be enough. So there's already, if you the mean here, maybe just modeling the mean is enough. I know that in my case it isn't. By the way, I would at this point like say thank you to Emmanuel Romeo, who jump engineer, who helped me out in going through that procedure as well. Thanks, Emmanuel, for giving me a heads up for FTE. Okay, we need a generalized regression here. Hit run, and then that dialog opens where you can choose different estimation methods. Basically, you could just try them. Then the model is going to be done. Nice thing is that up here, you're going to have a model comparison. So if you put in more than one, you will directly see the comparison of them. So how they behave and which has the best information criterion. Then you have to choose your whatever you want to go with. Be aware that some of something like best subset can take some computational time. So maybe go to see how far that should go. And okay, you chose then your model. You do then save the prediction formula of that estimation method you chose. You hit that, and then Jump will put that here, and then you have everything together what you need. This time in one place. You're going to take the profiler, put in your prediction formula for the harvest yield, and of course, of your online responses as well. Add them here. Depend how many you have modeled. Expand intermediate formulas as well, and click OK. I again scripted that, having that a little bit nicer. And then this comes up. You have your prediction formulas for PO2, your online responses, and your harvest year, dependency of the FPCs down here. And now I will just show you a short. If you turn on the FPC1, you can see what happens. So if you have a lower harvest yield, then it shows you that here you're basically on a rather low level here. We already learned that low levels of oxygen are not so good for a fermentation process. So that can be seen here as well. And if you have we have now more harvest, more titer, more product in your fermenter, you're going to see basically this goes up. That's good. So same behavior here. And you can already see here that here goes up. So it's positive for your process that the PO2 goes up in the end. Now, this is the point where at least I have to go to the subject matter expert and to give him that data, because he is the one who understands that. This level of analysis is maybe not good for a manager, but here you can really go into detail with all the subject matter expert on the, let's say, fermentation level. And having this option, this really speeds up your process understanding very much. And you can see the impact with the plots Jump gives you very, easily. And sharing that profiler with the process engineer gives you a real head start in what is important during the course of the process, and gives you really the opportunity to save a lot of time in finding that out. And yeah, if you do that by chance, find it out by chance, that's going to take so much longer. So don't do that. Yeah, I'm heading towards the end of my talk. And I want to say that the statistical analysis of fermentation data, JUMP really gives you the power to explore and visualize those complex processes very easy. You can deepen your process understanding and which process parameters are important, which interact, and which do I have to look at which time points of the process. And with the profilers and the different setups, JUMP really gives you the possibility to speak that one mutual languages to all levels, from technician to manager, so that really everybody can make more from the online and offline fermentation data and really speed up your biotech process development. Thanks for listening. I'm Benjamin Fürst from Clariant, and feel free to comment and ask questions over the available channels.
Thank you so much, Ben, for preparing that presentation for us. Ben is going to join us in just a second, but first we'd like to know a little bit more about you, our audience. So we're going to run our next poll. So do you think that what you've seen today could be helpful for you to speed up your process development? Yes, no, or not sure. We'll just give you a few seconds to answer that. It's just useful for us to know, how to pitch things in future and whether we've really hit the level there. And while you are completing that poll, I will remind you that you can ask questions, and Ben is here to answer those questions. So please do type in your questions into the GoToWebinar questions box, chat box, whatever it may call itself, depending on exactly how you've joined us, because it's really useful for us to make sure that we answer the questions that you have that occur to you throughout the presentation, or maybe just those nagging questions you're not sure about how to start, how to approach these sorts of problems in your own work. Now, for those of you who joined us late, we will be sending you a link to the full recorded version of this webinar, so don't worry if you missed the beginning. You'll be able to catch up in your own time. That will be in your inbox in a few days' time, along with a certificate for everybody who has joined us live. Right, how are we doing? I think we need just a few more seconds to vote, and then we will close that poll down and start going into your questions. I think that's probably enough. We've got an idea there of whether or not we really hit the level. So let's dive into these questions. We're going to get Ben up on screen now. Also in the background, if you ask any strongly JUMP themed questions that only a JUMP expert can answer, then Emmanuel is happy to jump in. Emmanuel, who was mentioned earlier in Ben's presentation as being the person who helped Ben set all of this up in the first place. Ben, thank you for joining us live. Questions are coming in as we speak. One thing that occurred to me though is, before JUMP and before we had this sort of software, and in particular the modeling involved in this sort of software, would it have even been possible to gain these sorts of insights? And if so, how would it have been done?
Without, it's going to be pretty hard. I can recognize that without a JUMP, probably, yeah. I have to put it this way: there are software packages out there which provide that knowledge behind JUMP, of course, but JUMP puts it together in a nice place, and you can use it in all sorts of ways without using different platforms. So that is like why I prefer to use in this context. You can do the nice graphical things I showed, and also doing all the fancy stuff with the pro version. So that kind of gathers up pretty well. You can do it, maybe each package in another software, maybe even better or faster, but here you can really put it all in one place. Which is very neat.
You'd have to bring together various different skills and abilities in order to be able to, especially to communicate it as well as actually do the research there. Okay, well, let's dive into some audience questions here. There's a jump on this. We'll come to Emmanuel for that later. So Functional Data Explorer seems, as you just demonstrated, it's very appropriate for analyzing quite a complex situation like this one, fermentation in your case. Are there other things that you can use it for?
Yeah, sure. Basically, you can use it on every kind of curved data. So whatever you have a response on your axis and whatever dimension you have, you can have, like, for instance, you say viscosity. You have a viscosity measured over a shear rate. So that's a functional data. Or you can think of spectrometry. So you have your spectrum over the wavelength. You can model that. So anything which has just a different, has a shape. Everything which is a shape you can put in there. Kinetics, you name it.
Excellent. So the follow-up to that, really, obviously you have very kindly spent quite a lot of time preparing this presentation for us, but in terms of the actual work, I mean, how much time does it take to prepare all of the data and tidy it up and so on, and work out, you know, what's the important points in terms of getting that data into JMP in the first place?
Yeah, that's quite a good one. Let's say that was my really first deep dive into JMP using that platform. That was quite a tough one, but yeah, that thanks on Emmanuel. I really mean that he gave me some head start there. Yeah, so data preparation depends where you stand. So do you have a process control system where you can just take your data off, or you just have a standalone PC somewhere in your lab and you draw the data from that in whatever fancy format it is? So that data preparation can take some real time. So, and I'm quite a fan of getting your raw data straight. So the raw data has to be neat and prepared. Don't do it in the fifth stage. Do it as early as possible to sum up data and make it nice that you can work with it, because all the things you haven't removed in the first place, they're going to turn up later and you're going to don't like that. So yeah, so depends on what systems you have. You collect them and then arrange them together. So let's say 20 to 40% of the time is maybe data preparation, and then the rest depends how deep you're going to go into the modeling and how complex the problem is. If you have easy curves, you don't have to fit so much. Look at diagnosis plots and look, does it fit good or not so good? So depending how complex your responses are there. And important points for data import. Yeah, you have to play around. You have your online data. You have to add your DOE parameters to the data set you have. You have to put some points together as early as possible and really have a look at those FTE in the platform. I showed that those cleanup tools. You can do cleanup, aligning data, and transforming data. That gives you don't have to do that by hand. So that is something you can do that at a later stage, because JMP provides an easy access to do that.
I guess by spending that time in advance, making sure that your data is properly prepared, you're going to save yourself a lot of time, a lot of heartache further down when things aren't working as expected because something hasn't been properly formatted. All too many researchers, I think, have legacy systems, have Excel spreadsheets, have various different versions from different machines, especially when we're talking about an approach like this, where you are looking at collecting data from monitoring of a process, as well as historical data based on research that you've done, and the sort of static data around the room and so on. You really do need to take that first step of just understanding what data you have, how do you have it, making sure that it's clean and tidy, formatted correctly, and only then can you really start to properly interrogate it.
May I add one thing? And it's really talking to that subject matter experts is a huge thing. So, and really understanding where the data comes from and involving those people, because it's not about you're the data scientist and you're the engineer and just going a silo and just flipping the data from there to there. Everybody who's involved and wants to gain more knowledge of it needs to understand that a little bit. And if you talk that mutual language and include the people in what you do, you can really push the projects much faster, because you not want to have the people here, the data scientists did that, I don't know what he did there, basically. Get the people on board and push to there where you want it.
I think we might bring Emmanuel in for this. Emmanuel, hopefully you're still with us and you can just pop up on camera quickly. Nandita asked what type of models are available in JUMP. Obviously, we've looked at one today. Emmanuel, thank you so much for joining us. Thank you for helping Ben get this set up in the first place. And once again, thank you, JUMP, for sponsoring and helping these events take place. So, what type of models are available in JUMP?
So what type of model? There is plenty. So it also depends at which step we are talking about. So regarding the functional data explorer, as Ben explained, the more traditional is B-spline. He has to use P-spline. There could be various reasons for that, but one is if you've got not the whole data set, or if there is a sudden change. So in that case, it's P-spline, and if there is a seasonality, it's Fourier. So all are about the functional data explorer. But after it also use the principal component to modelize his data. And here it's about generalized regression. And there is a lasso, ridge, elastic net. But as a general comment, I would say JUMP offers plenty of various kind of models depending what you're doing. So it starts from the traditional linear regression up to neural network, and I will not list all of them in between.
So somebody who is brand new to this, you've been asked to refine a process, you've been given a data set, and you've been told, luckily, we have JUMP for you to use. How would you go about taking those first steps?
So the first step, we traditionally start simple. So just with the graph builder capacities, just visualizing your data and trying to understand the relationship between one or multiple responses you are interested in and factors you are working with. So that, I would say, is the very first step. And visualization is highly critical to ensure the sanity of your data. Is there any outlier? Does the data make sense? The relationship makes sense? And starting and understanding then the relationship between the various variables.
Excellent. And then from there, there's a whole world that JUMP opens up that can allow you to really understand your data, understand your processes, and as we've seen with the Clariant example, to generate efficiency savings, to be better at doing what you do, just based on a better understanding of the data that's there in a way that realistically we couldn't have done just by working or walking through the process without understanding those fairly complex interactions and relationships that may not be predictable and may not even be sort of intuitive. You wouldn't intuit that this interaction would be there. It's only when you do a proper deep analysis of the data do you start to see these relationships come out.
Yes.
We are a few minutes over. I think, but we do still have a handful of questions here, but I think we've broadly covered them. So I think rather than make people wait over the hour that we said this would be, I think we will probably draw things to a close there. So Emmanuel, thank you for popping in. I hope that Nandita, that answered your question at the end there. Benjamin, thank you so much for preparing that excellent presentation and for joining us this week as well. Thank you again to JUMP, who have sponsored and support a whole series of these webinars. They'll be back with us in a few weeks' time for workshops, webinars, various other content that we put onto the website. They're a long-running partner of Chemistry World because we believe that they are trying to make things easier for chemists, help them make better decisions more efficiently, and help them do better research. And I say chemists, but of course this applies to all scientists, but chemists are our world, so that's where we are. So that is it for this Chemistry World webinar. Once again, you'll get a link to the recording in your inbox in the next couple of days, and that will also include a certificate for those of you who joined us live. If you weren't able to join us live this time, then I hope the recording was useful, and I implore you, if possible, to join us live in future, because it's your interaction that helps to really make these webinars tick. I'm Ben Valsler, Chemistry World's digital editor, and have a look at chemistryworld.com/webinars for other upcoming events that you can join us in and give us your feedback. And we will see you again for the next Chemistry World webinar. Thanks very much.